So let's get on with the flat earthers. And this is where I'm going to start it. I'm going to start by showing what I think of flat earthers. Okay, I think they're very ignorant people and actually very stupid. And I do not apologize. I'm trying not to offend them. It's just a fact. These people have very little understanding of physics, and their reasoning abilities are even worse. Now, I am on record, okay? I'm on record saying that the Flatlanders, the flat earthers, okay? These are people who are still as uneducated as they are. They are far smarter. They're like two notches above the mathematicians, okay? The mathematicians fare a lot worse than they do. And why do I say that? Well, the flat earthers are ignorant people because they never went to school. That's their problem. The mathematicians, on the other hand, the mathematical physicists, so-called physicists, they've gone to at least 10 years of schooling to get their PhDs, and then they come out talking nonsense. They talk about Big Bang creationism, which they later deny. They talk about black holes. They talk about zero-dimensional singularities. They talk about dark energy, whatever that is. They say it's a measure of their ignorance. And it's like, what is it, like 70%? So yeah, I think that really shows a little bit, it's a good number to put to the intelligence and the ignorance of the mathematicians. They tell you that a particle can be at two places at once, and that they can time travel, and that time dilates, and who knows what other nonsense that they learned by rote in college. So yeah, I have very little respect for the mathematicians, and in that sense, I put the flat earthers a little bit above mathematicians. Okay, so that's my starting point. Why do I start on the flat earthers? The other thing we should mention about the Flatlanders versus the mathematicians is that the mathematicians, they don't believe the Earth is flat. They believe the universe is flat. Okay, so yeah, forget about the Earth being flat. Anyways, we laid off last time. We abandoned at the point where I showed how a balloon moves forward in a car when the car accelerates. And that's kind of counterintuitive, because you would think that, when anything accelerates, like a car, a truck, a train, whatever, you would think things go backwards. Turns out with a balloon, it's the other way around. Okay, and it looks more or less like this. Okay, here it is. Give it a second here. So the car accelerates and the balloon goes forward. And that kind of makes you wonder, why is that the case? You know, what's going on? Is this some fancy trick? It really seems counterintuitive, right? Okay, and we covered that last time. And then here, together with that idea, you find that if you move a water jug, forward, any bubble of air that's, on the surface will also move forward. And again, that gives you an idea that what's happening is the water moves backwards. And because it moves backwards, it's got more density than the air, so the air moves forward. Okay, it's got like more strength than the air. Okay, the liquids essentially drive the air away. Okay, and it looks more or less like this. As soon as the car accelerates, okay, you can see the water goes back and the bubble of air goes forward. Okay, so the bubble of air goes in a counterintuitive direction. You would think that everything goes backwards, and here they're showing that it doesn't. And that's more or less the case with air inside a car as well, why it pushes a balloon forward. The air allegedly moves backwards, and because of that, the balloon moves forward. Okay, so this is the explanation. Okay, and so I asked $1 million question, and I'm a little disappointed with some of the answers that I got from the flat earthers. Okay, and again, they're not very smart people. And so let me show you what the problem is, what the question is. And it takes a long time for these people to understand the question. So I'm going to insist one more time, see if maybe one flat earther or another can understand the question. I just want them to understand the question. Forget about answering it now. Okay, and so here's the question, okay? You're on a subway or on a train, whatever, okay? And you're hanging on, right? Suddenly the subway moves forward, okay? You feel that you go backwards, okay? Something, for some reason you move backwards, okay? And there you can see it, the second figure, the one in the middle, moving backwards. And if it accelerates even further, you move even further back. Okay, so that's our experience. Okay, and the question is, why do we move backwards? That's the $1,000,000 question. You're standing still in the subway accelerates, you move backwards. Why do you move backwards? This is the $1,000,000 question, okay? And you'll hear some of the answers these people gave to this question, okay? I call it a simple question. For other people, it's not as simple, okay? And here's a dynamic version of something like that. You can see the car accelerates, and these two girls just fall off the truck. Why? What's pulling on them? Okay, that's the question. And people say, well, it's inertia. Well, that's not an answer. See, inertia is what we're trying to explain. In other words, we call this effect inertia, just like we call gravity an effect. We need the explanation for inertia. And you can't use concepts such as mass. You can't say field. You can't say wave. You can't say density. You can't use concepts. You have to tell me what physical object is in touch with the bodies of the girls that forces them down, that forces them, in other words, that creates that inertia effect. Okay, so that's the $1,000,000 question. Okay, what physical entity is in contact with the girls? If you say there's nothing in contact with the girls, which is what most people would like to answer, then you're doing this by black magic. You're saying that there's absolutely nothing in contact with them, and yet they are pulled off the truck. That you're saying that inertia works by magic. That's what you're saying in effect. Okay, let me repeat that. When the subway accelerates, you move backwards. Why do you move backwards? What's pushing or pulling on you in the opposite direction of the subway, of the acceleration of the subway? And you say nothing is pushing, nothing is pulling on me, then you're doing that effect known as inertia with black magic. Okay, that's the issue. Okay, so what did one person reply? Well, he said the following. He says, talking about the airplane, because I used the airplane example, which was a bad example for me to use, really, because these people are not smart enough to understand what I was talking about. You know, when you get on the airplane, they're already seated. That's when the airplane starts. It goes up in the air, it starts going at a constant rate, more or less. And at that time, you can stand up, go to the bathroom, go to the front of the airplane. You can do whatever you want because you're traveling at the same speed as the airplane. The issue is here, what happens when the airplane accelerates? What happens to you? Okay? Hopefully it throws you to the back of the plane. But they didn't understand that. So because they didn't understand that, they didn't answer the question. So this fellow says, because yes, we are in contact with the plane floor. However, we are not attached. Okay? The plane seats do not move because they are attached, not just in contact. So the answer to your question is merely structure. That's the answer to my question, structure. That's why when the airplane goes forward, you stay in place because you're part of the structure. That's what they're saying. And again, he's talking about constant acceleration or constant speed. That's not what I was talking about. I was saying, what if it accelerates? Okay, so again, he didn't understand the question. You can glue your shoes to the plane floor and you will feel like you are moving back, but you are kept in place as you are a part of the structure. Okay, he probably had a lot of help to figure all that out. Yeah, incredible the answer I got from him. And I think same fellow, I think he just put this up there. He says, horses go ahead, and you, the driver, lurches back until the wagon, which is tied to the horses, pulls you forward. So you say, giddy up, horses run, you go to the back. And then once you hit the back of the seat, now because the whole carriage is moving forward, it takes you with it. My God, I think this guy deserves a Nobel Prize for discovering that. I hope he did it all by himself, didn't need any help. Okay, another fella tries to answer the question, another flat earther. Nothing is pushing or pulling on me backwards in a plane. My body will move with the plane. Yeah, of course, if you're traveling at a constant speed, yes. But see, again, they don't understand that. If your mass of your body is at rest, it will go with the airplane's direction. Okay? When the airplane accelerates, it's the mass of the plane that makes the object inside it move. Mr. Duh, mass is not a physical object. So you cannot say mass does this and mass does that. And it's interesting that all these flat earthers, some of them go to high school, they make it that far. And they learn all these concepts like mass and force and energy in high school. You don't learn them in elementary school, but yeah, you do learn them in high school physics. And so they use the word mass, which comes from mathematical physics. Okay? And then they criticize mathematical physics, even though they use the same language that mathematical physics fed them. And that's where the problem is, because mathematical physics is nonsense. It's just math, has nothing to do with physics. Okay? And these people are trying to explain something like mathematicians try to explain something, and you cannot use the concepts, the abstract mathematical quantitative concepts of math to explain mechanisms of physics, which is what the entire planet out there is doing today. They're using words like field and wave and energy and mass, force, charge. All these are concepts. They're quantitative concepts. They have nothing to do in physics. In physics, you have to identify the physical object that is doing the pushing or pulling. Okay? Like, if a horse is pulling on you, you say, well, why was I pulled? Well, because it was a horse. You can't say it was a concept called force. Okay? You can't say that it was energy. You can't say it was a field. No such monster. You got to say it was a horse. And so on, And here this fellow says it's the mass. So he thinks he answered the question, not even by a long shot. Okay? But then he says, once my body does reach the back of the plane, I thought he says it travels at the same, it travels with the plane at first. He says, nothing is pushing or pulling me backwards in a plane. My body will move with the plane. Now he says, once my body does reach the back of the plane, this is how these people talk. They just talk in circles. Then we'll also start to move with the plane again, as you can't leave the plane through its solid body. Poor soul. Bless his soul. Anyways, these are the kinds of answers that they give. They don't understand the question. They use concepts of math to try to explain a mechanism, and they thought they answered the question. It was mass. That's what it was. And again, mass in mathematical physics has two definitions or two general notions. One is quantity of matter, and the other one is weight. Okay? Now, the mathematicians never use the quantity of matter. They always use weight. So weight and mass are always synonyms because mass is always weighed, and they give it to you in kilograms. Quantity of matter, they would have to say, that the bag of marbles has 1 trillion atoms, and they would specify it in terms of atoms. They would say the mass of this bag is 1 trillion atoms. That they could do. They never do that. They always say the mass of this bag is 1 kilogram or 1 pound or whatever. So they always give you the weight. So in mathematical physics, weight and mass are indistinguishable. And the only time they try to change that is to try to explain that, if you take that bag of marbles to the moon, its weight changes, but its mass remains the same. And the answer is no. The mass changed as much as the weight because we determine mass not by counting atoms, but by weighing. So when you weigh it on the moon, that's the mass of the bag of marbles. And until they count atoms and they express their masses in terms of quantity of atoms, they're not going to be doing mass. The mass of physics, which would be related to physics. As long as they use weight, a measurement instead of counting, okay? One thing is counting atoms, the other one is just weighing and giving you a measurement. Well, as long as they use measurement, they're doing mathematics. They're not doing physics at all. So, you can't use the word mass to explain anything anyways, even whether you use the weight or the quantity of matter notions of mass. Okay, we have another fellow, and I said, what causes the air to accumulate in the rear of the car? And the fellow says, the motion of the container, meaning the car, right, is what causes the air displacement inside it, causing the air to move. All he said is, the air moves. Yeah, I know the air moves. We're trying to find out why the air moves to the back of the car. Why doesn't the air move together with the car? Why does the density become greater in the back of the car? That's the million-dollar question. Okay, something came in contact with each molecule, each atom that comprises the air. Okay, something is in contact with each atom. And so when the car moves forward, the air is left behind. Otherwise, why would the air move backwards? How does the air know that it's got to move backwards? Okay, and this fellow says, well, I guess he would say is that the back of the car is pushing, I guess that's what he's thinking, pushing the air in the back of the car. And the question here is, why doesn't the whole block of air move forward? Why does all the air suddenly move to the back of the car? He still hasn't answered that question. He won't answer it until he identifies the physical object that is in contact with each atom, with each molecule. Okay? And here he contradicts himself. He says there, the motion of the container is what causes the air displacement inside it, causing the air to move. The solidity of the car container, again, is causing it to accumulate in the back of it. Again, he hasn't explained it. He just says, it is so. Okay, and that's not the question we ask. We ask, what is the cause? Okay, and here then he says, no air molecule is pulled anywhere. It merely falls back down to where it came from. So flat earthers have this idea that things that fall have been raised to begin with. This is their logic, if you can call it logic, okay? And there's another fellow that also says something along the same lines. But the point here is that these folks are saying, that before something falls, it must rise. Okay, that's essentially what they're saying. But this fellow has not explained what causes the air molecules to go to the back of the car. Okay, the only way he can explain that is if he tells us what is in contact with each molecule, each atom that comprises the air, then he would be able to explain it. But to say that it just goes to the back of the car because the container, somehow the motion of the container, he hasn't explained it. Well, what is he saying? The motion of the container pushes all the particles to the back? Is that what he's saying? So again, you have to tell me what pushes that last molecule that's close to your mouth, right? What pushes it back to the back of the room? That's what he's got to explain. Okay. And where did they get this stuff? Well, they get this stuff from Mr. Galileo. Some people say that it was Newton, but no, Newton did not come up with the laws of motion. They were there before he was born. Okay. And so this is the Galileo so-called law of inertia. Again, ridiculous notions that the mathematicians have that they call everything a law. In physics, we have no laws. It's in mathematics that they have laws. I don't know who enacted them, who legislated them, maybe God, I don't know. But this is the short version. A body will remain at rest unless it is acted upon by a force. A force? Maybe he meant the horse. See, a horse can act upon an object like a carriage there, but not a force. There's no physical object called force. So you cannot say a force does this, a force does that. Okay? Not in physics. You cannot cut corners and say, well, I'm going to use euphemisms or figures of speech. No, you can't. You got to be literal. So when you look at this, you say it was the horse that pulled on the carriage, on the buggy. Okay? That you can say. But you can't say a force pulled on the buggy. Okay? And so again, mathematicians invented these words, and then they extrapolated them onto physics. No, when you come into physics, you have to put a physical object there. You can't say the force did it, the energy did it, the mass did it, the charge did it. You can't use any concepts. Mathematical concept, quantitative concept. You have to use physical objects. You got to tell me what physical object moved this and moved that. Okay, that's the issue. Okay, so Galileo did not figure it out. Again, all these people talk about force and other concepts, and that's when they screwed up because they're doing math, they're not doing physics. Okay, so let's distinguish those two. Okay, so a lot of these people, they harp on experiments. They want to do experiments. So let's do an experiment. I mean, they all want to do experiments. Not only the flat earthers, the electric universe, John Chappell group, the establishment. Everybody talks about experiments. That's what they inherited from the 17th century so-called scientific revolution. Okay, so let's do an experiment. And it's known as Newton's bucket. Okay, we're going to try to figure out if there is something, a physical entity, okay, in contact with the air inside a car. Okay, is that possible, or is it that we're all crazy? We're just saying that air just, the container hit the the air and that's why it accumulated. No, we have to identify something, and Newton's bucket is a good experiment for all those flat earthers to become acquainted with, okay? And let's go through it real quick so they learn something maybe. Here it is. Okay, here's Newton's bucket, okay? We fill a bucket with water, and we hang it from a rope, okay? Now we're going to torque the rope as much as we can, and then we let go. As soon as we let go, the water momentarily, well, the bucket spins, right? The water initially stays flat, the surface stays flat. But as the bucket spins more and more, what you get is this concavity. You have concave water. The water rises at the edges and sinks in the center of the bucket, okay? And when the rope stops spinning or torquing, when the bucket stops, the water is still twirling around and with that concave surface. Okay, so this is Newton's bucket experiment. He did it in those days. I think 1687, somewhere around there maybe. Anyways, this is the experiment. Okay, you twirl a bucket and something which is not the bucket, okay, by the way, and I'm not going to go through all that. You can look it up. Something outside of the bucket In fact, outside of the earth is pulling on that water. Let me repeat that for all flat earthers out there. Something outside the earth is pulling on the water, on the molecules of water. Okay? Now, this is where it gets interesting because flat earthers say, well, how do you know that? And blah, blah, blah. And they start, getting all excited. Okay? So let's go step by step. Let's show the flat earthers how much intelligence they really have. Okay? So here was Newton's version of what pulled on the water at the edges of the pail, okay, and why it formed that concave surface, okay. Well, first of all, let me show you. This is, again, you see the skater, and when a skater twirls, her arms are being pulled by something, okay? And the question is, what is pulling on her arms? She feels her arms stretching outwards. And you don't have to take my word for it. You can go and talk to one of these skaters and they'll tell you that when they spin, their arms are like being pulled somewhere. And hopefully it's not the air around her that's not pulling on her arms. So what you have to tell me is what is pulling on her arms. And this is the same situation as the air inside a car. This is exactly the same situation as those girls who were dropped out of the wagon there and they fell on the floor because the car accelerated. So all these are the same situation. Something is pulling on matter here on Earth. And Newton was saying that it was, and in fact, all the mathematicians out there in this are saying that it's something outside the Earth. And for once, they got this one right. They just don't know what it is that's pulling from outside the Earth. Okay. So what's Newton's version? Here it is. Newton says it's space. Okay. He said that when that bucket twirls, it twirls with respect to space. There is an absolute space out there, and everything gauges its motion with respect to space. That was his version of it. Leibniz did not agree with him, but he had no reply to that. He couldn't figure it out either. Mathematician from Germany. Okay, a couple of centuries later, we have another fellow come in, and his name was Ernst Mach, and he came up with the notion that it's not space, but mass. Okay, he was talking about the mass of the stars. And again, now these people talk about mass, but mass is not a physical object. You cannot say mass pulls on water. Okay, you cannot say gravity pulls on water. Those are irrational statements. Okay, and so again, one of the things you got to keep in mind is that you can't just keep putting concepts there and hopefully getting by with just a concept and saying you have this invisible mathematical concept, quantitative. It's just a quantity with a number with a unit, and that's pulling on the pail. That's pulling on the water inside the pail. So this is the problem. And so they summarize it as this, essentially Mach's principle, created by Einstein, who gave him credit for it. He said the paradox of mass there influences inertia here. Whereas there is outside the universe. He said it was the stars that pull somehow, okay, from a distance, action at a distance, somehow pull on the molecules of water. Okay, do we have that? And I should have brought what I showed several times already, and that's Richard Muller, professor at Berkeley, and he said every atom in your body is being pulled by every atom on Earth. Okay, so we have all these notions out there. Here's Einstein's version of what is pulling on you. In his case, he says it's warp time. Okay. And NASA said they proved it with a project known as Gravity Probe B. They proved frame dragging. They say that the Earth drags space around itself. This is the nonsense with which all these PhDs at NASA, Houston probably, came up with. Warp time. So this is what all these people have come up with. In other words, to this day, we have no answer to the question. They have a partial answer that's the universe, all the stars somehow are pulling on us. They're in contact with us somehow. And the way the mathematicians answer is, well, it's mass, it's gravity. But those are concepts. You can't say gravity pulls on you. Gravity is what you're trying to explain. You can't say inertia pulls on you. Inertia is what you're trying to explain. And you can't say mass pulls on you. Mass is what you're trying to explain. Why does mass, increase its speed, right, acceleration, as it falls towards the center of the Earth? Okay, and you can do that on your own. You can take a bowling ball and weigh it on top of Mount Everest or a high point somewhere, weigh it at the low point, sea level, whatever, and you'll find that there's a difference in weight, very small one if you do it at the same place, more or less, up, down, and you'll find that there's a small difference in weight. Okay, and so the acceleration is greater as you reach the center of the Earth. So what you have to explain, what is pulling on you. Now, if you say it's push, okay, fine, explain it with push. But you got to explain, but in order to explain, you need to identify the physical object that is pushing or pulling on you. Just like you would explain how you're pulling on a donkey, same thing. You got to explain what is pulling or pushing on whatever that's causing, these accelerations. And again, if you have the skater moving around, right, the more she spins, the more her arms are being pulled outwards. Why are they being pulled outwards? What's pulling on them? Okay, that's what you got to answer. And in order to answer that, you have to identify the physical object that is in contact with her hands, her arms, her body. Okay, mathematicians say it's something outside the Earth. They never figured it out. Some say it's space. Some say it's the mass of the stars, which is more or less the idea they have today. And then, which is Mach's principle, essentially. And then you have Einstein said it's warp time. So that's state-of-the-art explanation for you of inertia. Okay, moving on, more or less the same issue. We have gravity. Okay, we had inertia just a minute ago, so now let's do a little bit of gravity. And here a fellow says the cause the pencil drops. You let go of the pencil. Okay, my famous experiment. You let go of the pencil, and it falls down. Okay, and so what the flat earthers all say says, well, the reason it falls is because you pushed it up. This is their logic, if you can call it logic. So I pushed it up, right? I pushed it up, and now because there's nothing to stop it, that's why it falls down. That's their answer. Okay, so they haven't answered anything because I need to know what's in contact with a pencil. Okay, but let's address that first issue. So the cause of pencil drops is the absence of matter beneath it. Okay, great. The object will fall down until it meets a more dense medium that resists it. Not that hard. Poor fella, he must have worked all night to come up with that answer. Okay, I know it's hard for them. You picked it up, you dropped it, you observed the effect of your own cause. So the cause, see, I dropped it, I didn't push it down. I just let go. See, let me make sure we understand. I'm not going to push it down. In fact, I can push it upwards and it'll fall down anyway. It still falls down, whether I push it up or down. So it's not that I pushed it down. Okay, I want to make sure that people understand it. I just let go of it and it falls. So no, I'm not the cause of why it goes down. Okay, so no, he answered it. he didn't answer it at all. But we have stuff like asteroids. Do you believe in asteroids, flat earthers? Do you believe in meteorites? You can see them every day. They fall on Earth. There's all kinds of debris falling on the Earth from outside the Earth. We didn't throw that debris out there and wait for it to come down. We don't throw meteorites out there and then say, okay, now it's going to fall. Meteorites come from heaven, God, I don't know, I don't care. But they don't come from the Earth. They come from outside the Earth, fall on the Earth. No one pushed it upwards. Okay? And so the question is, why do they fall to Earth? What's causing those meteorites, those stones, right, to fall to Earth? That's the million-dollar question for you. Okay? So don't tell me that I lifted the pencil and that's why it fell. Because I didn't lift the meteorite for it to fall. Okay, we got that? Very simple stuff, well, for normal people, okay? But maybe you can get past that. And another fellow says more or less the same thing. Show us how a spoon or bowling ball can fall without it being lifted up first. You don't seem to understand that most objects just don't float in midair or fall upwards after being lifted and then released. And again, meteorites, don't talk about stuff that you are familiar with. Talk about stuff that you're not as familiar with, apparently, which are meteorites, asteroids. Let me show you a list here, impromptu list that I've got. And that's, the first one says, chunk of rock falling downhill. Now, you can argue that in that case, maybe the mountain pushed it up originally because, the mountain grew over time, right? There are all kinds of tectonic movements, and so they tend to push mountains upwards, at least that's the theory. And so the question is, you could argue that the rock was pushed up originally. Fine. Bird laying an egg in a nest. Okay, again, we have the situation where the um, bird, uh, she was probably not pregnant when she went up there, but you could say that the egg was manufactured in her body, and so whatever she had in her body, she took up to the nest to begin with before the egg could drop to the floor. So again, you can argue that, right? Rain, snow, fog, same thing. You could argue that there are, these um, hot and cold air that mix up there, so you could argue that the air went up first before it came down as rain or fog. Okay, but here we have other situations like the air itself that covers the earth, right? Uh, we didn't lift that, okay? And so the question is, why does the air fall? Because there's air that falls, and the question is, did that air first rise? Is that what you're saying? That there are air currents that took it up? Well, you have stratosphere. You can have that air up there, and then some of that air trickles down. Eventually, some of those atoms, some of those molecules. Okay, and so the question is, does air fall, and did we put the air up there? How about the moon? Especially for flat earthers, the moon, when it rolls around the flat Earth, as moon and the sun, by the way, does it roll around the flat Earth like they say, and they're just these disks? What does that fall? Did we put the moon up there? Also, we raised the moon up there before it fell, and why doesn't it fall? Please tell me why. Okay, what causes it to go around? Why doesn't it fall? Okay, you would think that it would fall, right? What is it, a balloon? Oh, it's not. You don't believe in spherical balloons. Maybe it's a flat balloon, a pancake balloon. And again, asteroids and comets, meteorites, they fall to Earth and or to any object, and we never put them up there. Okay, so to say that objects must be first pushed up before they fall down, that's a non-answer. Okay, we don't need to put anything up for it to fall. Okay. Okay, Fowler says along the same lines, and this all goes to what we're going to be talking about today, which is noumena. Okay, and here we see this fellow says, yes, we have a flat moon. These guys are real. Use your eyes, not your mind. Well, obviously you haven't used your mind very much. Okay, I grant that. You are telling us that there is something between the magnets we can't see. Exactly. I'm saying exactly that. I'm saying there's something between these two magnets, the two round ones, okay, the two round ones there, and they stick together. And there's something here we can't see, but I can already feel it pulling. And it's taking it out of my hand. And it's not that I feel something pushing from the outside. It's something from within, okay, between the magnets. So yeah, there's something there. And you might say, well, let's continue. It says, you are stating something is there without demonstrating this. How is that not black magic? Well, it's the other way around. If you tell me that there is nothing between these two magnets, okay, because you can't see or touch them, which is what all these people want, experiments of some kind. Experiments meaning sight and hands, sight and touch, eyes and hands, right? That's what they're looking at. They're saying, let's go to the lab and see if we can see what's in there. And of course, they're not going to see anything because, again, whatever's in here is invisible and intangible, okay? We can't touch it with our hands, at least. We can touch it with iron filings, but we can't interview the iron filing and find out what it touched. That's the problem, okay? We can't touch it. And for sure, we can't see it. But if you say that there's nothing there, then you're saying this happens by black magic. It just happens. No explanation whatsoever. No mechanism, no cause. It just happens. It's one is pulling on the other, and because you can't see anything there, you say, well, there's nothing there. Okay, and yeah, that's going to take us to the subject matter today. Okay, but so let's just rub it in what the question we need to answer. Flat earthers need to answer these questions. Here you are in the subway. Okay, subway moves forward. You are physically compelled backwards. What is pulling on you? Why don't you travel together with the accelerate? Why don't you accelerate together with the subway or the train or whatever or the bus? Why does the bus go and leave you behind? What's holding on to you? What's pulling on you? What's pushing on you? Something is holding on to you. Okay, like that fellow said, if you're stuck to the ground, you would be moving with the vehicle. But since we're not stuck to the ground, obviously you move backwards. I mean, that's our experience, right? The question is, why do you move backwards? Okay, you say, well, because the other guy moved forward. Yeah, but you could. Are you standing still? Is that what you're saying? Okay, what's holding you there? Why don't you move with a car even though you're not attached to the car? I mean, you should be able to move with a car. Why is there a difference between being attached and not being attached? That's the question. Okay, so you got to tell me what's holding on to you, or what's pushing or pulling on you. What invisible, intangible entity is in contact with your body that compels you to, be pulled backwards when the vehicle accelerates? That's the $1,000,000 question. Okay, and to say, well, it's density, it's inertia, it's gravity. No, that's what we're trying to find out. What is gravity? What is inertia? What is mass? That's the question. Okay, that's the ultimate part of the question. And the only way you're going to answer is identifying the invisible, intangible objects that Mother Nature uses. Okay, here we have, someone says, there are infamous flat earther who fully believe the moon landings and ISS. I don't think so. Now, these people are dumber than normal flat earthers, okay? They're even dumber. Because if they believe that we went to the moon, and if they believe that we have the ISS rolling around there, well, we have satellites out there. And this is how many satellites we have out there, okay? 7,400, okay, individual satellites in space at the end of April 2021. So if we have these many satellites from different countries, any one of them can take a picture of the Earth from far away or from a certain distance and tell you that the Earth is spherical, that it's got a curved border. And, people say, well, how do you believe that? Why do you believe that it's got a curved horizon, et cetera, et cetera? You're saying all these satellites, different countries, they're all in cahoots and they're all trying to fool you. Oh, man. If I were you, I'd watch my shadow every day. Who knows? Maybe they're after you, No, any satellite from any country that's out there. I mean, you have Japan, you have so many countries that sent satellites up there. Any one of them can take a picture of the Earth. In fact, you have Google Earth, and hopefully you see it roundish, roundish surface. If with so many satellites out there, to say that all of these are hoaxes, that all the pictures that they've taken, for example, the ISS rolling around the Earth shows always a curvature. If you say that's a hoax, well, where did you get that? Why do you think it's a hoax? All countries are hoaxing you? And again, you must be scared of your own shadow then. Okay, and so someone gave me a good response for what I can consider now a definition of a flat earther. It says, by the uninitiated, I mean people who believe in nothing but what they can grasp in their hands, who will not allow that action or anything invisible to have real existence. That's more or less summarizes the flat earther. Flat earther does not believe in what we're going to call today noumena. And we'll find out what that is all about. But essentially, a flat earther only wants experiments and wants anything that they can see and touch. That's how prehistoric they are. They say, that's all I can put my finger on and say, this is true. And anything else is just a lie, a hoax by the intelligence agencies. So they don't want to believe anything other than that. And so if they can't see it and they can't touch it, it doesn't exist. That's essentially what it comes out to. And again, it's because they have the wrong definitions, irrational definitions, the see-touch criteria for object, the see-touch criteria for exist and existence. And those are not the definitions of object. Those are not the definitions of exist. That's where the problem is. So what does a Flatlander want? Well, he wants proof. So the definition that you just saw is very specific for them. It's right on the money. We want science based on our human senses, except common sense. Okay, all other senses. They think it's all about see and touch, especially those two. Smell, which is touch. Hearing, which is also touch. All those are touch. You have to have some contact. But essentially it's see and touch. And so they don't want to get away from that. And it's like their world is so small, that you ask them, is a table an object? Yeah. Why is it an object? Because I can see it and I can touch it. Is a chair an object? Yeah. Why? Because I can see it and touch it. Tree, I can see and touch it. Rock, I can see and touch it. So is the rock that's on the other side of the planet that you cannot see or touch, is that an object? Does that exist? Okay, so that's the issue. Because if you're going to do everything by see and touch, the moon does not exist for the blind man because he can't see it. And air must not exist for you because you can't see it. You say, well, I can touch it. Yeah, but you can't see it. What are you touching? Please draw for me what you're touching. That invisible stuff that touches your hand. That's what we want to find out what it is. What is air? Is it a ghost? Is it a spirit? Okay. Please draw what air is. That's the question. Okay, it says an object is not what I can see and touch. Well, that was my definition. So he's saying an object is not what I can see and touch. Wow, I guess I learned something new today. Yeah, I guess he did. Whether he learned it or not, I don't know. How is one ever? Uh, how is one to ever proof something exists if he cannot see or touch it? And you can see how they confuse the word object with the word exist. They make those two synonyms. They think an object is that which you can see and touch, and existence is that which you can see and touch. So for them, the word object and the word exist are synonyms, and that's been the case with 99% of humanity today. Okay? So in that sense, they all have the same notion that an object is that which you can see and touch. Okay, and so he says, how do you prove it? He thinks he's going to prove existence. You prove the existence of the chair by touching it and sitting on it and seeing it. And so again, is the chair that's on the other side of the planet, is that an object, first of all? Because you can't see or touch it, so I guess it's not an object. So what is the Japanese or the Australian sitting on? I mean, is he sitting on an object? Does that object exist? And you're saying, I got to see it and touch it, but otherwise it doesn't exist. So again, their notion is their little world inside their tiny minds, okay? It's this little tiny world that they have there, and their whole world just goes in that area. Okay, I thought maybe someone cut me off there. So they have this small world, and it's just whatever they can see and touch. They cannot go beyond that. They receive a call maybe on their cell phone from Japan. Where's that coming from? Does that person exist? I mean, you can't see him or touch him. Does that person exist? Is that person an object? And they don't have the mental capacity to understand what I just said. They don't realize that there's someone who called them on the phone. Who do they think called them? God? I mean, I don't know. So you want us to accept all these concepts without proof. See, again, they harp on proof, on evidence. They don't want an explanation. They don't want a mechanism. What they want is for you to convince them. That's the issue, okay? And if they can't see or touch it, they say, I'm not convinced. And so you can't see or touch the person who's on the other side of the planet who's calling you, so that person is not an object, that person doesn't exist. Okay, and so take your word for their existence. And again, they mix the word object with exist. That's one, and then exist is not see or touch. Okay, so these are the gross errors in logic, if you can call what they do logic at all, rationality. And they just mix these things up, object with exist, and why? Because they don't have definitions. That's the issue. They don't work off of scientific definitions. They use the definitions of ordinary speech, and in their tiny little minds, that's what they live with. That's all they've got. So when they come into the scientific world, they bring those definitions of common speech, of everyday speech, and they think they're making sense. They say, oh yeah, object, that which I can see and touch, exist, that which I can see and touch. And what about the objects that you can't see or touch? Does the air exist? I mean, you can't see it. You say you touch it, but what did you touch? Maybe you touched the ghost. I don't know. Okay, so these are the conclusions. Flat earthers misunderstand basic physics. They are very, very ignorant people. Okay, no apologies there whatsoever. Okay, they harp on belief rather than on explanation. They don't want an explanation. They don't want you to explain a mechanism. What they want is for them for you to convince them. They want you to harp on their belief system, and they withhold belief because they say you haven't proven that there's air, because I can't see it. And you haven't proven that Australian is sitting on a chair because I can't see or touch it. So that chair doesn't exist. And that's the guy that called you just now. He was sitting down calling you, but he doesn't believe that because he doesn't see it. He can't touch it. So he says, that Australian doesn't exist. And he's not an object either. But someone called him, who knows. Okay, maybe it was his mother from New York. He doesn't see her or touch her either, but he says, oh, Ma, how are you? Who are you talking to? I mean, you can't see or touch her. Okay, so what do flat earthers have to do? Well, they have to answer the cause of inertia, okay? And these are some of the things that they can address. One, what causes the air to go to the back of the car, okay? What causes the air to go back? What thing is in contact with the air molecules? Draw it. I want you to draw whatever's in contact with the air molecules. And again, Mach's principle, Newton's bucket, says that something outside the Earth is pulling on every atom on Earth. And when the skater rotates, her arms are pulled outwards. Tell me why. What's pulling on her arms? Okay, or maybe pushing. I don't know. Maybe you Want to do push gravity or push inertia? Fine. What pushes and pulls or pulls the pen to the floor? Okay, we have the pen or pencil, right? Let go of it. Again, I'm not pushing it downwards. It just falls. Why does it go down? Why does it go upwards? That's the question. Okay. Why doesn't I want it to go? Someday I want it to go to the ceiling. Okay. And what brings two magnets together? Okay. You're saying there's nothing here. Then you're doing black magic. That's what you're doing. Because you're saying that this comes together with that one for no reason whatsoever. And it always does the same thing. You know, it just comes together. In fact, if I hold it lightly, you can see how it just goes by itself. And you're saying there's nothing here simply because you can't see or touch it. Okay? That's the issue for you. Because for you, an object is that which can be seen or touched, and existence is that which you can see or touch. And again, I can show you that you can't see or touch the person on the other side of the planet, meaning that that's an irrational definition, an irrational notion that you have of what an object is and what existence means. Okay? Action at a distance, any action at a distance, black magic. Like everything from mathematical physics. You know, they talk about entanglement, they talk about gravity, they can't explain it. Why? Because they never identify the physical object that we cannot see or touch. So you cannot use the see-touch criteria. That's the issue. Okay, and if you're using concepts such as field or mass or density, you know, any of those, you're doing black magic. Because you cannot say density does this and mass does that. You can't use the concepts as physical objects to explain a mechanism. Okay, so we got that. And what you need to do is identify the invisible, intangible mediators that Mother Nature uses to do her daily work. Mother Nature, Father Universe, God, the devil, whoever you pray to, I don't care. I need to find out what those physical objects are, those invisible, intangible objects that they use every day to do gravity, density, mass, whatever you want to call it. Okay, so that's the homework, okay, if you can do it. And final note, Fowler says, let me put it over here, says, first telling why the concept of visualization is so important, and then immediately after discarding Einstein's theories completely. Laugh out loud. Well, I'm not sure he's laughing at himself because he's laughing out of ignorance, because Einstein never had any visualization whatsoever. Okay, so let's get that straight. All of Einstein's nonsense was all abstract math. Never did he have a mechanism, a physical mechanism for how the universe works. To say that space-time warpage, you know, is what causes gravity, that's absolute poppycock. Okay, so you can't say that he illustrated anything, that he made something visual for us. Absolutely not. In fact, to this day, most mathematicians will tell you that they have no answer to that. When you say, well, how about space-time, this canvas? Now you're taking the analogy too literally. That's the answer you get. In other words, they don't have, to this day, a physical mechanism, objects, things that explain how gravity works, how inertia works, how mass works. They don't have that. All they have is mathematical equations, mathematical concepts. That's it. Okay, so we got that. Now you know what your homework is. Okay, figure out inertia. Figure out why that girl spins and her arms come outwards. That's what you got to figure out. And I would advise that you look up Mach principle, Newton's bucket, so that you become familiarized with the invisible, intangible things that are in contact with our bodies from outside the earth.